Hello again. In this video, I'm going to go over Objective 6 from section R6, which is about rationalizing the denominator of a radical expression. Now, you may remember from an earlier section we talked about what it means for a radical to be simplified, and there was 4 conditions that needed to be satisfied in order for a radical to be considered simplified. And that was from section R3, so I'm just going to pull that back up. These are the 4 conditions that you need in order for a radical to be considered simplified. And I want to focus in on the third one. The third one said no denominator of a fraction may contain a radical. And so what we're going to do in this video is talk about how we simplify radicals that do not meet this third condition. Okay, and so I'm just going to look at a couple of examples. Now this first example, example 11a, notice that we do have a radical in the denominator. And so this is not considered simplified. Okay, and so what do we do then? Okay, so here's what we do. We rationalize the denominator. That's what this is called. What we're going to do is we're going to multiply this radical by another radical that looks exactly the same, square root of x, as many times as we need to until we no longer have a radical in the denominator. Well, in this case, I think we just need 1 square root of x. Now, if you multiply the bottom by square root of x, you have to multiply the top by square root of x because you have to multiply by 1 in order for this fraction not to change its value. You have to multiply it by 1. If you multiply by anything other than 1, then you're going to change the value of it. So you have to multiply by 1 because we can't change the value of it. Now, so this is equal to 1, so this is completely legitimate. But this is going to change the form of it. Okay, it's not going to change the value, but it is going to change the way it looks. Okay, so let's see what happens. Now on the bottom, I get square root of x times the square root of x. And of course on top, I just get 5 times the square root of x. But what's important here is that on the bottom, this can be written as the square root of x times x. That's a property of radicals. Okay, these are equal. These are the same thing. Okay, which happens to be x squared, or the square root of x squared. And the square root of x squared is simply x. And so now we no longer have a radical in the denominator, and now this is considered simplified. Okay, so this is what we do when we only have a single radical in the denominator. Now I would like to say, before we go on to part B, that let's say this was 5 over the cube root of x. Okay, now we have a single radical in the denominator, so all we need to do is continue to multiply by this same radical until we get rid of the radical. But in this case, you're going to have to multiply by the cube root of x 2 times, not just once. You're going to need 2 of them here. And of course, if I do that on the bottom, I'm going to have to multiply it by the same thing on top because it has to equal 1. Okay? And so the reason I need 3 of them total is because when I multiply these together, I get the cube root of x times x times x. And of course, on the top here, I just get 5 times the cube root of x times the cube root of x. But the important thing here is now that I have 3 x's underneath this radical, in other words, x cubed, when I take the cube root of x cubed, I do get x. Okay, and so this no longer has a radical in the denominator. Okay, so I just want you to be aware of that. You need to continue to multiply by this radical until you have enough of them so that when you take the cube root of whatever's inside the radical, you end up getting just x back. For another example is just to show you, if this was the fourth root of x in the denominator, well, then I'd have to multiply by the fourth root of x 3 more times to give me a total of 4 in order for this to no longer have a radical in the denominator. Okay, and so what would happen down here is you would get the fourth root of x to the fourth, and of course on top you would just get 5 times the fourth root of x times the fourth root of x times the fourth root of x. But the important point is that this is now x. The fourth root of x to the fourth is simply x. Okay, and you have rationalized the denominator, right? The denominator no longer has a radical in it. Okay, so this is how we handle a case where we have a single radical in the denominator. You just multiply that radical by itself as many times as you need to until you can get rid of that radical, on top and bottom, of course. Okay, so now let's look at a different case. Part B, notice now we do have radicals in the denominator, but now we have a binomial in the denominator as well. We've got 2 terms now instead of 1. Okay, and we need to handle this differently. We can't simply multiply this by the square root of 7 or the square root of 5 and hope to get rid of both of these radicals. Right? I mean, if we're going to simplify this, we need to get rid of both of the radicals. Okay, so we've got 2 issues here, not just one. Up here, all we had to do was get rid of this one radical. Now we have to get rid of both of these radicals. Okay, so let me show you how to handle this case. So what we're going to do in this case is we're going to multiply the bottom here by the conjugate of this denominator. Okay, of this square root of 7 minus the square root of 5, we're going to multiply this by its conjugate. Now you may or may not remember the conjugate. The conjugate of this would be the square root of 7 plus the square root of 5. So you have to change the sign in front of one of the radicals. Okay, so we're going to change the sign in front of this radical. We're going to make this one a plus. Okay, so the conjugate is going to be the square root of 7 plus the square root of 5. And we have to multiply that on top as well, because again, this has to equal 1. You have to multiply this radical by 1, otherwise you change the value of the radical. Okay, so we multiply the top and bottom by the conjugate of the denominator. And then I'm going to go ahead and FOIL out the bottom here and see what happens. So we have to, first, outer, inner, last, right? So the first would be the square root of 7 times the square root of 7. Okay, then the outer would be the square root of 7 times the square root of 5. All right, then the inner would be negative square root of 5 times 7. And now remember, the order in which I multiply doesn't matter, so I'm going to switch the order and just say square root of 7 and then times the square root of 5. And that way it makes it clear that these cancel out. Okay, and then the last would be the square root of 5 times the square root of negative 5. Of course, this will be negative because a negative times a positive is negative. And then you get square root of 5 times the square root of 5. Okay, in the course on top, you just get 4 times the square root of 7 plus the square root of 5. Okay, so now these middle terms cancel out. One's plus and one's minus, okay, but they cancel to 0. And then the square root of 7 times the square root of 7 That's the square root of 7 times 7, which is the square root of 49, and that's simply 7. Which is nice because this no longer has a radical in it after we multiply these together. And the same thing's going to happen here. When you take the square root of 5 and multiply it by the square root of 5, you get the square root of 5 times 5, which is the square root of 25, and that's 5. So it no longer has a radical. Okay, so let's just write that down. We're left with this on top, and then on the bottom, this becomes 7. These cancel out, and then this becomes 5, so minus 5. And then 7 minus 5, of course, is 2. And so we no longer have a radical in the denominator. So by multiplying this by its conjugate, we were able to get rid of the radicals in the denominator. Now, just to finish this off, we can simplify this a little bit further because 4 divided by 2 is just 2. So it's the same as 2 times the quantity square root of 7 plus square root of 5. Now, last thing I want to talk about before we're done with this example is why did multiplying by the conjugate work? Why did we do that? And the reason it works is because if you change the sign, right, because the conjugate, we change the sign in front of one of the radicals, right? So we chose to change the sign of this one to a plus. And the reason we did that is because when you FOIL this out, the outer term, you get a square root of 7 times the square root of 5, and it's positive. But then the inner, you get a negative square root of 7 times the square root of 5. And so those cancel out, right? One's plus and one's minus. So by changing the sign of this radical here to a plus, we were forcing the middle term to cancel out. We knew one of them would be a plus and the other would be a minus. And those radicals go away because they cancel out. These radicals go away, the first and the last go away because they're being multiplied by themselves. Square root of 7 times the square root of 7 ends up just being 7. The square root of 5 times the square root of 5 ends up just being 5. And so that's really nice, right? That's the reason we multiplied by the conjugate. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.